Hey guys, I'm making a little project here the weekend. The weather's been really hot lately, and I just happened to move from making videos, so today I said I'll make one. And we're going to be making a 250 watt dummy load out of nothing more than a heat sink from an old power supply, a few nuts, washers and bolts, a couple screws, piece of circuit board from an old, I don't know if it was supposed to be a tuner or what it was out of, or supposed to be for, but just a leftover piece of circuit board, I guess for some kind of a project or something. This was given to me there by Dwayne. He went off Alpha Bravo a while ago, so I said I'd put this one to use for this project. And he also donated this power resistor, which is a 250 watts 50 ohm resistor, believe it or not. It's marked 250N50. It's really small. hard to believe that is good for 250 watts. It's crazy actually. So my idea with this is to mount the circuit board on top of the heatsink. Put a couple SO239s in it, one or two, not sure. One for sure, I don't know if I'll put the other one in or not. I'll put the, if it works out, I'm going to put the resistor right there, right in the center here. Something with gay. Put that there like that. I've got me bolts. I'm going to bolt the circuit board down. Washers give it a bit of strength. And on the other side, I've got this fan. So it's just wide enough that it should fit this heatsink. I think it's pretty tight. At least we'll see once it drills the holes and try to screw it in there. But yeah. That's the idea, anyway. So, if you're interested in hanging around and watching me either build a working 250 watt dummy load or blow up a 250 watt dummy load, stay tuned. Okay, got me two SO239 connectors. I'll mount them on the circuit board, like so. Got some nuts and stuff here, bolts and whatnot. I need two more. Okay, now I got enough. Alright. Side. I get the Dremel, and what I'll do, I'll put actually I should do here. Put a washer. Should put a washer under them screws. Just because we're dealing with a circuit board here, we don't want to crack it on us now, do we? Turn off that fan. You probably can't hear me over that fan. One. two SO239s connected, installed. And they're gonna sit like that. Actually, should do is, yeah, I'm gonna change one of these to an actual end connector. That way I can test repeaters or whatever as well. So yeah, so I think I'll have one SO239 and one end connector. That's exactly what I'm gonna do. Okay. So SO239 on this side, and I got an end connector on this side, so depending on what I want to connect to this thing. So the next thing I'm going to do is I'm going to run a piece of copper wire straight across between the center and the center, between here and here. So a nice heavy piece of copper wire across here. That's effectively joining both of the connectors together. So we're going to do that next. Still might cut off these screw ends. I don't know yet. Anyway, again, we're making a 250 watt dummy load. Parts were donated to me by Dwayne, V1 Alpha Bravo. This is one of the parts. It's a 250 watt 50 ohm resistor, marked 250N50, right on it. The circuit board, he also donated that a few months ago. It was part of some kind of a kit that neither one of us have any idea what it was for, but I figured, hey, it'd be perfect for this one because it fits perfectly on top of this heatsink. It fits like it's made to go on this. So now I'll solder a piece of wire across these two terminals and we'll go from there. I'll foil off the enamel. I know there's probably other ways of doing this, but whatever works. The main thing is the enamel comes off the wire. It's a round foil I'm using here too. Flat edge, but also rounded. So that's that one. So I need to go over to here. That'll do. This is an enamel copper wire from an old transformer, if you're wondering. So, can't just strictly solder to it, it's just not going to work. Tin my wire. Try not to burn my fingers in the process. One side. Just like that. Yeah. I gotta put a bit of water on my sponge. So I keep my tip clean here. So now I'm going to solder that to there. But before I do that, I also want to solder this. I also want to tend to center this as well. Remember, we got our little resistor there. I want to attach that to this. Well, it's close to the center of that wire I can anyway. Again, boys, whatever works. There ain't no commercial construction technique here or nothing. After all, this is amateur radio, not professional radio. So that one goes there. Solder this one onto there. Over here again, make sure we got a good connection. There we go. A little bit uphill there on this side. There we go. That's better. Alright. So now, we'll take the other little piece of copper wire that we had, and I'm going to solder that onto there, and then that's going to solder onto the resistor. I'm hoping. Okay, so that's what I got done. So this piece of copper wire here is going to attach to the resistor, to the power resistor. At least that's what I want it to do. Question is, how in the name of God am I going to attach that and be able to solder that when it's underneath this? Probably not going to be easy. So what I might do, actually, I might take this wire, run it straight through this, and attach it to the resistor on the other side. I think that'd make a whole lot more sense, I think. Because there's just, I don't know if we're going to get this in there. But well, it just might work. I might be able to get it in there. Let's see, how high does this need to be? Pretty much the same level, which means this wire so I can trim the wire to right about there. Trim off the wire there. Tin it again. There we go, that one. Just got to line up with the resistor. Now, tin it. This is going to be a hell of a job to tin it afterwards. So, might as well tin it now. Alright. Now we need to turn the wire down so it's down flat. Or level, I should say, not flat. And yes, that is hot. Alright, so something like that. Because what I want to do is get the resistor when it's mounted and just solder the wire directly to the resistor, like that. Good any luck. So now, I gotta figure out where the resistor is going to sit. On this. I had to drill my hole to match where the resistor is sitting. Right there. So use an existing hole by the looks of it. I'd rather use that small one there. going to work. I have to cut off all these screws, these edges, in order to get my tip in there to solder that wire. So yeah, off goes all these. There we go. All cut off flush. Alright. Now we'll be able to get in there. She's gonna be tough, that's for sure. But we're going in. So I must mount the resistor right there if possible. Right there if possible. Mark it and mount it and see what happens. Okay boys, after much back and forth and change stuff around, blah blah blah. So I got my circuit board mounted. Two connectors are mounted. I got the board mounted to the heatsink. Bolted down. Nylon nuts here. A couple nuts on the inside to keep it tight. I got some rubber insulation, basically vulcanizing tape actually, running underneath the board on the edges here, just to keep the board from wanting to, go left or right or whatever. So getting ground from here to there. The resistor I end up putting on this side and bored a hole straight down through and soldered it on there. There's no continuity whatsoever to the chassis here, so we're good. And I put some heatsink compound underneath the resistor. So yeah, and I foiled off so it was on bare metal. Just getting a good connection to the surface of this heatsink. So now I'm going to try some continuity just to make sure we don't have a short between the chassis and the center conductor. I want to see 50 ohms here, not a dead short. So that's what we're going to do here now. First I'm going to do continuity. The dead short should be just 0.006. So we get 60 ohms, 60 ohms. And between the pin and here, which is good. And do the same thing here to here, which is good. Golden. Alright. So, perfect. Now, only thing left to do now is the fan. There was a mount a fan at the bottom of this. If I had a couple small fans, could almost put them on top and let the air blow straight down. Or I could just use this just the way it is. This doesn't really matter. Either way, I'll be fine. The board doesn't move. So the board's nice and tight on the heatsink here. What I wanted to do originally was put the resistor on the same side on this side over here, but I couldn't get my soldering iron down there to do my connection, so I had to do it, the resistor on this side, and run my wire straight through and connect it that way. Yeah. Not too bad, I don't think. Now, do I leave it just like this? Or should I put a fan on it? Fan would keep the resistor cool, no doubt. Let's see. Let's see if I can mount that fan on there. Let's see what happens. Hey guys, just finished dummy load. I'm turning the light on here so you can see a bit better. There we go. That's the resistor. Actually ohmed out to be like 65 ohms, whatever. But anyway, so I have the radio's antenna cable connected directly to this thing, and now we're going to do, and this day we're calibrate. Meter light is out, so I'm gonna have to kind of just calibrate it. Put on SWR. Put her on power. There we have it. The RF dummy load do in fact work. No problem at all. Happy with that. Still haven't decided if I'm going to put a fan on there or not. It's just one of them things, I don't know if I'm going to or not. Kind of thinking to mount it straight up there. Take out the one I got here that I've had forever. This one here. Done a video on this one, you know, a long time ago. I don't know if you remember the video I did on that, but I've used that one for a long time. And I might just change it out to this one instead. Anyway, it does work. It works indeed. It works fine. So yeah, I suggest, boys, if you got if you need the dummy load to get yourself one of them resistors, have at it. It's pretty cool, actually. On a side note, I was just curious because I did have a link of wire going from one connector straight to the other, and I was curious if she would pass power. So I have this power that's going into this watt meter. I want to see how much power is passing from here through this, through that. So much power is passing here. So we got 2 watts channel 1, 3 watts on channel 40. So yeah, it does work. Another thing I was just curious about, folks, Have you ever tried, to put a 50 ohm load in line with your coax? I know everybody uses an antenna tuner to achieve your 50 ohms. So what would happen if you put an in and out direct link with your 50 ohm resistor to ground through this? Would it still work? Or would it bleed signal and RF to ground? How much power would this still do? Because we do know that with the meter or without, we do know it's passing power because we put it on the watt meter over here. But I think I'd be pretty curious to find out how it would work in series with a bad antenna. Not really a bad antenna, but an antenna that's not fully tuned. Because the radio directly from here is showing 50 ohms, even though the antenna might be showing could show a little mismatch. But the 50 ohm resistor could be making up the impedance mismatch. Something like an antenna tuner would do, sort of thing. Would this kind of a setup do the same thing, or you think you'd lose power? Just something for you to think about. Anyway, folks, 7:30, and we'll catch you later on Radionuts 63. Oh, by the way, I have another project coming up, and you might be interested in it. Anyway, folks, catch you shortly. It's Radionuts 63. I'm out of here.